Welcome back. Today we're going to talk about something that probably keeps a lot of you up at night, building a really solid rollback strategy for multi-cloud canary deployments. It's one thing to push code out, but when things go wrong, how ready are you really to recover with zero drama? So here's our game plan. We'll start by setting the scene with a high-stakes rollback scenario. Then we'll do a quick refresher on what canary deployments are all about. From there, we'll get into the fun stuff, architecting a safe rollback, breaking it down into 3 core pillars, and wrapping it all up with a resilient blueprint you can actually use. All right, let's just dive right in. You can talk about deployment strategies all day, but the real test, it isn't when things go right. It's how you handle failure. This is that moment of truth. Okay, just picture it. Your new feature, your canary, is live. The dashboards that were all green and happy a second ago, they're now lighting up like a Christmas tree, but with all the wrong colors. Error rates are climbing, support tickets are starting to flood in, and you know that every single second of this costs you money, and worse, it costs you user trust. So, what's your move? This is exactly the scenario we're planning for. Now, before we architect the escape plan, let's just make sure we're all on the same page. A canary deployment is, without a doubt, a fantastic strategy for lowering risk, but it is not a silver bullet. It's a proactive measure that absolutely 100% needs a reactive backup plan. So what is it really? Well, at its heart, a canary deployment is all about testing your new code in the real world, but with a safety net. You expose just a small group of actual users to the new version. It's literally the modern software version of the canary in a coal mine. If the canary is fine, hey, the environment is safe for everyone else. And here's what that looks like on a good day, the happy path, right? You deploy the new version, you send a tiny bit of traffic its way, you watch your metrics like a hawk, and if everything looks good, you slowly open the floodgates until everyone's on the new version. Smooth sailing. But our focus today is on what happens when step 3 goes terribly wrong. Okay, so now let's architect the solution. When things do go wrong, just slamming a giant undo button isn't a strategy. That's a panic move. A real safe rollback is an engineered, pre-planned recovery process. And this right here, this is the big mindset shift. We have to stop thinking about a rollback as just going backward. It's not. It's a forward-moving recovery plan that has to coordinate traffic, your infrastructure, and your data state, all in perfect harmony across all of your cloud environments. So what does this recovery plan actually look like under the hood? Well, it really stands on 3 critical technical pillars. They have to work together or the whole thing falls apart. Let's break them down. Pillar number 1. The very first thing you have to do is control the user impact. This is all about getting your users away from the broken version as fast as humanly or really as fast as automatically possible. This is your first line of defense. The procedure here has to be instant and automated. Step 1, your traffic management layer, your load balancers, your service mesh, whatever you use, has to stop sending any new user sessions to that canary. Step 2, all traffic, a full 100% of it, gets routed immediately back to the stable version that was working just fine moments ago. This contains the blast radius instantly. Okay, so your users are safe. They're back on the stable version. But now, that stable version is getting hit with all the traffic again. Pillar 2 is all about making sure your infrastructure can handle it. So, check this out. This is a pretty typical state during, let's say, a 10% canary. You can see most of your compute resources, your pods, your VMs, are still running the stable version. Just a small slice is running the new canary code. And then bam, you execute the rollback. The infrastructure has to react just as quickly. The canary replicas get scaled down to 0. We don't need them anymore. While the stable version scales right back up to 100% to absorb that full traffic load. This prevents a performance nosedive. All right, now for the part that trips everyone up. Shifting traffic and scaling replicas, that's the easy stuff, relatively speaking. Managing your data, especially your database, this is where rollbacks get incredibly complicated and, frankly, pretty scary. And why is it so hard? Well, think about it. The new canary version might have changed the database schema. It might have written data in a new format that the old version of the code has no idea how to read. You've got to worry about data corruption, transactions that were halfway through, other services that depend on that data. It's a mess. The most important takeaway here is to have a database strategy before you even deploy. As you can see, the safest, lowest risk path is to only make backward compatible changes.
That means the old code can still read and write to the database just fine. For trickier schema updates, you might use something called the expand/contract pattern. That's where you add new things first, migrate the code, and then later, much later, you remove the old stuff. It lets both versions coexist for a while. Of course, for total isolation, you could do a full blue/green database, but wow, that gets complex and expensive fast. The key is choosing the right patterns for your change.
Okay, so let's tie all this together. Let's combine these three pillars, traffic, infrastructure, and data, into a blueprint that you can actually take action on. This is what turns that moment of panic into a calm, proactive, resilient recovery. So here's a checklist. Take this back to your team. Ask these questions. Is your traffic reversal automated? Can your infrastructure scale correctly on demand? Have you actually planned for the database problem? And maybe the most important question of all, do you test your rollback plan with the same seriousness that you test your deployment plan? Because if you don't, it's not a plan, it's just a hope. And that really leads to the final thought I want to leave you with. We spend so much time and energy perfecting our deployment pipelines, right? We make them automated, resilient, fast. But have you given that same level of architectural care to your escape hatch? Because in this multi-cloud world, your deployment is only as strong as your rollback. Thanks for tuning in.